student, in this way we can find the equality. So if there is no inequality, probability x lie between a to b, then we must perform equality for continuous, for because this is the continuous random variable. Student, if we does not make equality, for example, so if we does not make equality, for example, students, so uh, the graph will be discontinuous. For example, this is x equal to a, and if we are not, for example, x not equal to a, so in this point graph must be break. Graph must be break. This is what we call breaking function, stepwise function, splitting function. This is not continuous. This function is not becomes a continuous function. So if there is no inequality between the intervals, then we must perform equality first of all. We can write as equal to this is involved, this is including, this is close interval, for example x lie between a to b. Okay, so this is the property. If we are going to find probability x lie between a to b, then integrate a to b of f of x dx, just like in previous, for example, slide. And if we are going to find student probability x greater than a, this can also be written as x less greater than equal to a. For example, equality must be there. If there is no equality, we apply the equality. So this is what we call continuous random variable. But in student discrete random variable, we does not perform the equality. If there is no inequality between the, for example, greater than a, less than a, so we find the probability greater than a, less than a. For example, we could not make equality, or we could not perform equality ourselves. So this is continuous random variable. If there is no any equality written in the form of here, we must perform equality, because equality there also there, equality must be present in the continuous random variable. So how could you find this probability? If you are going to find integral a to infinity, greater than a stand for a to infinity. See in the graph, for example, in this graph, for example, see this one, for example, this is what we call a, and this is what we have b, and we are going to find, probability, we are going to find probability x greater than a, just like that. See this one, x greater than a, x greater than equal to a, for example, x greater than a, x greater than equal to a. So greater than a stand for, see in the graph again, greater than equal to a stand for a to infinity. We are going to integrate a to infinity. So this is what we call probability a to infinity. See this one in the, for example, a small graph. For example, apply in the small graph in this concept, just like that. For example, see this one, if we are going to find probability, this is the curve, and this is, for example, a, okay, and this is the plus infinity. And if we are going to find probability x greater than equal to s, then a to infinity, this is the whole area, integrate a to infinity of fx. Okay, so and so the first one formula, if we are going to find less than a, then you can write less than equal to a, equality must be there. And how could you find, for example, this is another graph, for example, this is x equal to a, for example, okay, this is x equal to plus infinity, for example, so this is what we call method or graph of condition by help of meaning. So x equal to a, for example, okay, now this is x equal to a, and for example this is x equal to infinity, and you are going to find probability x less than equal to a. So x less than equal to a stand for, this is a, and we are going to find this less than region, x less than equal to a. So we are going to integrate, what is this is, for example, minus infinity. So a to, for example, minus infinity to a, we are going to integrate minus infinity to a of fx. So integrate this function, for example, just like that. And this one is already clear in the previous slide, already mentioned here. For example, probability x equal to a, and this is x equal to b, and we are going to find probability x a to b. So integrate x a to b, we can get the probability. So This is the properties of PDF, student. So by help of these properties and by help of this PDF function, we can find PDF, and by help of these we can find probability density function. We are going to consider example. See this one. This is continuous random variable function, reaction temperature in degree centigrade controlled by the experiments, and continuous random variable having the following density function. See this one, student. F of x equal to x square upon 3, where x lie between -1 to 2. So see this one, there is no any equality are there, no any equality for example there. So we can apply equality as well. We can find equality just like that. For example, I written in the separate form, f of x is equal to just simple function x square upon 3, where x lie between -1 to 2. Equality is not there, you must perform equality, apply the equality, and fx equal to 0 elsewhere. So students, see, understand this function. If x lie between -1 to -2 inclusive all these values, if x lie between -1 to how could you identify this is continuous random variable function? Because this is the interval range, this is the range in which we are going to predict this is the continuous random variable. So if x lie between -1 to 2, then fx equal to x square upon 3. This is the function of x. And if x lie beyond these limits, for example greater than -1, and for example this is or less than -1, for example less than -1, or greater than 2, for example 3 4 5, so all these point f(x) equal to 0. So if you are going to find, see this one, if you are going to find f of 3 image at x equal to 3, so what is x equal to 3 in this limit? No, in this limit. Elsewhere stand for by help of these limit, if x lie between these two these, then fx equal to this. But if x lie between beyond these two limits, for example these interval, so elsewhere f of x equal to 0. So f of x or f of 3 is equal to, consider f of 3 is equal to, for example what, x equal to 3, where in here put x equal to 3, no, the x equal to that does not involve in the interval. So f of 3 is equal to 0 elsewhere. And if we are going to find f of 100, for example, also equal to 0. If we are going to find f of -4, for example, see this one, student, -4 in this interval, no, in this interval elsewhere. So this is also let's suppose to be equal to 0. So this is what we have images, what we have function. Okay, now verify that it is a density function, student. First of all, verify it is the density function. So what is the definition of density function? There are two definition, for example, of density function. First of all, we discuss f of x is greater than equal to 0. The first part, see the solution of the first part. For example, here the first part, the first property, f of x is greater than equal to 0 for all values of x, right? For all values of x. So greater than equal to 0, this means that positive answer for all values of x. So solve this one. For all values of x, how could you solve for all value? You could not solve for all values of x. You have to solve by taking lower limit and upper limit. So first of all, find image at lower limit. For example, x equal to -1. See this one, f of -1 is equal to, so put x equal to -1. Student, this is the lower and upper limit of this interval. So find the image at x equal to lower limit and find the image at x equal to upper limit. So lower limit, x equal to -1, put x equal to -1 over here. So -1 square divided by 3, which is equal to 1 upon 3. This is the image at x equal to -1. Now find image at x equal to, now in next step over here, image at x equal to upper limit, which is 2. For example 2 is the upper limit. For example, we have to find image at x equal to 2. So 2 whole square divided by 3, because 2 included in this interval, so we put x equal to 2 whole square divided by 3, which is equal to 4 upon 3. Now what is this student? At lower limit, image becomes equal to 1 upon 3. At upper limit, image also becomes equal to 4 upon 3. Both are greater than 0, positive. Both are greater than 0, positive. So if image at x equal to lower limit and x equal to upper limit becomes positive, see this one, positive, this also becomes positive, then first property has been proved. For example, first property, f of x is greater than equal to 0 for all values of x. So prove, this is implies that you can write just like that, prove that f of x is greater than equal to 0 for all values of x. Prove, first property has been proved. For example, now we are going to prove the for example, second property. What is the second property? Right over here, for example, second property is equal to integral area under the curve must be equal to, for example, 1. So what is the second property of yeah, this function? Area under the curve minus infinity to plus infinity f of x dx must be equal to 1. Okay, see this one, this is the second property of PDF, probability density function. First of all, f of x is greater than equal to 0 for all values of x. Second one is area under the curve integral must be equal to 1. From this is minus infinity and plus infinity stand for lower limit and students upper limit. Okay, now I explain first property again. The first property said that image at x all point must be positive. This is fx greater than 0. So we cannot find, for example, the image at x all points. For example, we must find lower limit image. This is the lower limit of the function, this is the upper limit of the function. We must find the image at x equal to -1 and at x equal to 2, lower limit and upper limit, by putting x equal to -1 over here in the first part of the function, because it involves including in that interval. Put x equal to -1, for example, and then put x equal to 2, the upper limit of same function. For example, both are included in that function. So first of all, put x equal to -1 over here and solve. You may get 1 upon 3. Then second, put x equal to 2, then you can get 1 upon 4 upon 3. So both answer, these both answer becomes positive, not negative. If any one becomes negative, then this is not PDF, student. This is maybe continuous random variable function, but not PDF, because PDF having said that f of x is greater than 0 for all values of x. So this is proof, f of x is greater. First property has been proved. We find lower limit and upper limit. In between them, there are so many infinite numbers are there. So how could you find, for example, prove one by one? So in lower and upper limit. So this is the first property. Now second property, integral area under the curve must be equal to 1. So put the values of area under the curve. See this one, student. The second property proof in the definition. For example, integral minus infinity to plus infinity f of dx equal to, see this one, student. Minus infinity means the lower limit of our given function, plus infinity means the upper limit of our given function. See this one, -1 to 2. So for example, minus infinity means the lower limit of our given function, -1, and plus infinity means the upper limit of given function, which is 2. Okay, so these are all meanings having there. Minus infinity means lower limit and plus infinity means upper limit of our given any function. If my our lower limit is 0, then for example, minus in minus infinity we can write 0 to something, integrate. So this is very easily integrate from this limit to this limit of whole function x square upon 3 of dx, and solve this one. Very simple, no any conclusion I think are there. Simple integration, we can get 1. After solving you can get 1. So this is the area under the curve becomes equal to 1. Prove that area under the curve right hand side. Second property also prove that. So you may write over here, hence hence given function hence given function hence given function is a PDF. For example, this is a PDF function. So this is what we call PDF, probability density function. Okay, student. Now we are going to find probabilities of several number. For example, now next part, find probability x lie between 0 to 1. How could you find probability x lie between 0 to 1? You can see that here x a greater than 0, there is no inequality are there. But in the property we also describe that if there is no inequality are there, you must find equality. For example, you must write equality into the form of equality. So first of all, in this for example condition, you write equality for example. So this is what we call probability x lie between 0 to 1. You have to find probability x lie between. How could you find? Integrate 0 to 1 of f of x. So you can get just like that. For example, integrate. How could you find probability? First of all, write equal to x lie between 0 to, for example, 1 is equal to integrate, for example, 0 to 1 f of x dx. So put the value of f of x equal to x square upon 3, and then solve. You may get 1 upon 9. So these all things are you uh, cross check by help of your calculation. So this is first part. Now second part, student, similar numerical. Now you have to find probability x less than 0. How could you find? Integrate x less than 0 stand for x less than equal to 0. So this is stand for, this is the upper limit. The upper limit x less than equal to 0 stand for, we have to find probability till 0. For example, what about the lower limit? Student, what about the lower limit? Lower limit is the our given function. What is our given function? This is the lower limit. So if we are going to find probability x less than or less than equal to something, then this number is actually the upper limit of its integral. But the lower limit, what is the lower limit? Lower limit is actually the for example lower limit of our given function. What is the lower limit of our given function? -1. So write this one, x less than equal to 0, 0, lower limit of our given function -1, integrate of f of x, put the value of f of x, solve this one, you may get answer 1 upon 9. So these all are properties. By help of these properties, student, these are this is less than equal to a, so integrate minus infinity to a, this is the limit belongs to upper limit, or this is the limit belongs to upper limit, because we have to find area x less than equal to a. So this is the actually the upper limit of the given integral. But what is the lower limit? Minus infinity. Minus infinity stand for the lower limit of our given function. What is the lower limit of our given function? -1. So that's why written in the -1 to 0 f of x, put values of f of x, solve this one, check the answer 1 upon 9. Now next one, probability x greater than equal to 1. So student, greater than equal to 1 stand for, this is actually the lower limit of the integral 1, just like that. And how could you find greater than? What is the greater than? The upper limit of the, find the upper limit of given function. This is upper limit of, what is the upper limit of given function? 2. See this one in again in the formula. See this one. If we are going to find probability x less than greater than a or greater than equal to a, then this must be the lower limit of the integral, but the upper limit is equal to infinity. Infinity stand for the upper limit of our given function, which is equal to 2. So that's why we are going to integrate 1 to 2 of f of x, put the values of f of x, and then solve 7 upon 9. It will become 7 upon 9. So student, this is what we have, probability density function, in which we are going to discuss for example, how could you find PDF? By help of PDF we can find probabilities of several points, and we prove the PDF, yeah, probability for example density function. Now another function is said to be the cumulative distribution function, CDF. What is cumulative distribution function, student? It may be represented by capital Fx, and we write into the simplest form. See this one, student, f of x CDF stand for, this is capital Fx stand for CDF's cumulative distribution function, and this is defined to be probability x less than equal to x. See this one, student, the probability, the CDF function must be provide less than equal to x probability. This one, CDF cannot be provide greater than probability. If you are going to find probability greater than by help of CDF, then 1 minus already discussed in the previous, for example, Poisson distribution. So CDF capital Fx may be defined as integral minus infinity to x, lower limit to x, x is the upper limit, there is no any value, random variable, for example, of PDF, this is PDF of dx of integral. In this formula, student, we write f of t dt. Actually, t is the parameter, it is not necessary. You may follow this formula. This is cumulative distribution function. So copy this formula. For example, this is cumulative distribution function, integral minus infinity to x. See this one, integral minus infinity to x, for example, and applied on PDF, for example, applied on PDF, just like that, integral, for example, minus infinity to x applied, this is PDF. So this is what we call cumulative distribution function. So capital Fx, students, see this notation, stand for CDF, and small fx stand for PDF. Just remember all these things. So this is what we call CDF. So integral of PDF, see this, integral of PDF becomes equal to CDF, and CDF always provide this probability less than equal to x. We cannot find probability greater than, and if we, anybody says that find probability x greater than, then we find in the next slide on the numerical by taking 1 minus. So integral minus infinity is the lower limit of a given function, and upper limit is remains x because the random variable x. If we are going to, anybody says that, for example, see this one, f of, for example, y, f of y, capital F of y. So how could you find probability y less than equal to y in form of y, random variable y? Then how could you make the integral? Integral minus infinity to y, for example, f of y into dy, this is PDF. So also this is what we call CDF dy, sorry, this is not dx, dy, integration with respect to x. So f of y is said to be the PDF, and this capital F of y is said to be the CDF. Similarly, just like that, this is the PDF. So integral of PDF, it becomes having these limit equal to CDF, or x lie between minus infinity to plus infinity. Over here, for example, in this formula, x lie between minus infinity to plus infinity, for example, any values from minus infinity to plus infinity, real number, for example. Okay, now this student, this is what we call CDF. What are the advantage of CDF? There is an alternate method for finding probability. This is the first method for finding probability by help of PDF. First of all, prove PDF function and then find probability several point. But this is alternate function, CDF. First of all, find CDF by help of this method, by help of this formula, then find probabilities of several event. You can find probability just like that we discuss in the next slide, for example. One more thing, student, see this one. If if you have CDF, by integration of PDF, solve this one and make a function CDF. But if you go back to the PDF, for example, so how could you find the properties of integration? Remember, all of you, for example, if you integrate f of x, for example, becomes equal to CDF, then the apply first derivative, see this one, d of capital Fx upon dx, first derivative of CDF becomes equal to PDF. So see this one, d upon dx applied on capital Fx must be equal to small fx, PDF. So all these condition, all these value, for example, you may apply by help of this number. Okay, so this is what we have, the relation between PDF and CDF. So if you are going to find the integral of something then this is becomes the answer. Then you can find derivative with respect to x becomes the original function. So this is the same thing. The integral of pdf becomes equal to cdf, but you have to find derivative. After finding cdf, you apply first derivative with respect to x on cdf becomes equal to pdf. So this is what we have another definition of, for example, pdf. So these are properties of cdf, student. CDF f of minus infinity lower limit, if we are going to put lower limit on CDF becomes equal to 0, and if we are going to put upper limit of the CDF plus infinity becomes equal to 1. So these answer, student, these are fixed answers. These are, for example, students, fixed answer. The lower limit image must be equal to 0, the upper limit image must be equal to 1, for example. So CDF always lie between 0 to 1. See this one, capital fx cdf always lie between 0 to 1, can never be, for example, exceed from these points. Okay, now another property, probability x less than equal to a. If you are going to find probability x less by help of cdf, then just take in image. See this one, just take in image at x equal to a, just take in image at x equal to a. So this is probability x less than equal to a. Just take in image, not find any form of integral. Another formula, if you are going to find probability x greater than a, then you cannot find probability x greater than a, because we discussed earlier, this is the CDF defined to be always in less than equal to form. So we are going to find probability greater than a, then 1 minus f of a, just like look like just like that. Probability x greater than a, we can write 1 minus probability x less than equal to a, just like that. First of all, 1 minus, take 1 minus. If we are going to find greater than probability, then take 1 minus x less than equal to a, 1 minus x less than equal to a. Okay, so this is what we have, cumulative distribution function, 1 minus probability x less than equal to a. So first of all, convert greater than into the less than, just like that already we discussed in Poisson probability distribution of the previous classes. So 1 minus, first of all convert into the less than, because we cannot find probability greater than by help of CDF. So take in 1 minus of probability, this one, 1 minus of probability less than a. Now you can write 1 minus this function. How could you write less than equal to a? Just f of a, take in image at x equal to a, just okay. So this is what we have, greater than a. This is the method. These all are method for finding probability by help of CDF, not PDF. PDF is the previous, for example, slide, we integrate from there number to number, but in CDF we can find very easily probability, just taking the image. If we are going to find greater than, then 1 minus f of a. Now next property of CDF, if we are going to find probability x lie between a to b, this is double interval. We already just find similar property by help of PDF, but in CDF very easy. But in CDF, take the image at upper limit of CDF, this is b upper limit, take image at upper limit of CDF minus take image lower limit of the CDF of f of b minus f of a, just taking the image and subtracting those two images answers, you can get probability between a to b. So this is the another third formula for finding probabilities by help of CDF. And the last one we already discussed, the first derivative of CDF becomes equal to PDF. Okay, now this is what we call, student, cumulative distribution function. Taking an example of cumulative distribution function, student, this is the simple similar example. Take PDF, for example, this is 3.11. What is the PDF? Already we discussed in the previous slide. This is the PDF, student, x square upon 3, where x lie between -1 to 2, inclusive all limits, for example, and 0 elsewhere. This is the PDF, student. We have given PDF and we have to find CDF. CDF, for example, we have to find CDF. So what is the formula for finding? This is the formula in form of f of t, not this is not necessary. You have to write, for example, just like that, f of x is equal to, for example, integral minus infinity to x f of x dx, just simple, not write into the form of t for example. So putting the values of fx, what is fx, this is the fx. Okay, so I solve over here, f of x equal to integral x square upon 3 into dx, putting the values of now putting the values of limit. Now minus infinity, what is minus infinity? 0. 0? No, minus infinity stand for lower limit of our given function. What is the lower limit? This is minus 1. So uh, minus infinity means minus 1 to x. X remains the x, random variable remains the random variables. So minus infinity means the lower limit of our given function, which is equal to minus 1. So integrate this one, integrate minus 1 to x, solve, you can get x cube plus 1 divided by 9. So student, this is the CDF. This is the method which it, see this one, this is CDF. Okay, now student, we are going to make complete CDF. We are going to make it complete, it by complete CDF. This is not complete CDF, this is accurate CDF, or although this is not by mistake. We have to complete, we have to solve accurately by help of integration, but this is not complete CDF. I can say that complete, how could you make complete CDF? See this one, see this one for making complete CDF. Student, this CDF you may check, apply, find image at x equal to lower limit. What is the lower limit? For example, in PDF, for example, find image at CDF lower limit, and find image CDF at upper limit also. Find the image in both points. Remember this one, CDF, find the image by help of CDF. This is the CDF, this is the CDF. Now find the image, put x equal to minus 1 over here, minus 1 cube plus 1 divided by 9. What is the answer? 0. Now see this one, put x equal to 2, 2 cube f of 2, f of 2, 2 whole cube plus 1 divided by 9 whole cube, which is equal to what? 8, 1, 9 upon 9, 1. See this answer, this is the, this will become 0 in visible form. Okay, and this is becomes 1. So after finding CDF, after finding CDF, put the lower limit of given function in the x equal to CDF, and put the upper limit, find the image, lower limit and upper limit. This images become 0 and 1. Students, how could you find this images become 0 and 1? See this one, f of minus infinity, the image at x equal to lower limit becomes equal to 0. The image at x equal to upper limit becomes equal to 1. Necessary, this is less necessary. This answer could not be anything, for example, except 0 and 1. The image at x equal to lower limit of CDF must be 0. The image at x equal to upper limit of CDF must be equal to 1. See this one. Is lower limit image becomes equal to 0? Yes. Is upper limit image becomes equal to 1? Yes. So hence proof this is accurate CDF. This is accurate CDF, not mistake. We are not going to mistake by applying the calculation or by helping the integration calculation. So student, find the lower limit image, which always becomes equal to 0. The upper limit image always becomes equal to 0. Now how could you write the complete CDF? Write a bracket, f of x equal to curly bracket, and write equal to CDF original answer into the middle point, x cube plus 1 upon 9, and write the limit, same limit in the, for example, middle point of in which PDF are given, for example. Now in this answer above, in this answer above, write lower limit answer which is equal to 0, and the below, after we write the upper limit answer 1. Always this answer becomes 0 and 1, student. So this is also CDF answer. So 0 write over above of the given function, and 1 write below of the not given function, CDF function, for example. Now what is the limit? How could you write the limit? x lie between -1 to 2. So write in the in front of 0 x less than -1, just like that, this limit. And write in front of 1, which is the upper answer, x greater than this answer 2. So these two answer, lower and upper limit over here, -1 and 2. And we find equality. If there is no any equality, for example, we write the equality. But if there is an equality, for example, you don't, student, if you write equality on both sides, for example, so write the equality over here, write the equality of here also, like, doesn't make any difference, doesn't make any difference. Equality all this there, always is there in continuous random variable. So student, this is what we have, continue CDF, cumulative distribution function.